Hello friends, in this video we will discuss about the important problem, design a combinational circuit that generates the 9's complement of a BCD digit. This question is from Digital Logic Design by M. Morris Mano textbook. So to design the combinational circuit, first we should follow the design procedure. The design procedure is having many steps. The first one is problem description. Describes the given problem as develop a logic circuit to generate a 9's complement of a BCD digit. Okay. Next one, number of input variables required. Based on the given problem description, we should identify the number of input variables required. Here, the input is BCD, so that the number of input variables required are 4. Those are labeled as ABCD. Because BCD means the digits should be 0 to 9 only. Because the decimal digits should write in binary form. The decimal digits are 0 to 9. So the largest decimal digit is 9. 9 in binary 1001. So it requires 4 bits. So that it needs 4 input variables. Those are labeled with the ABCD. Next one, number of output variables required. Number of output variables also 4 because we have to find the 9's complement of this BCD digit. So the 9's complement is obtained by subtracting a BCD digit from 9. This is the 9's complement of the number. Okay. So that 9 minus the BCD digit, which also gives the 9 to 0 digits. Okay. So the largest digit again we have 9. So that again it requires only 4 bits. So that the number of output variables should be 4. Those are labeled with the W, X, Y, Z. Next one, prepare a truth table based on the relationship between the input and output. Next one, obtain simplified Boolean expressions using K-maps. Next one, draw the logic circuit diagram. Now, first we should develop the truth table. Truth table means which is having different columns. The first column says that the number of BCD digits, these are from 0 to 9. Now, BCD in binary form, this is the input. So we have to write these BCD digits in binary. So A, B, C, D are 4 input variables based on the binary weights 1, 2, 4, and 8. We should write the equivalent binary from 0, 0, 0, 0 to 1, 0, 0, 1. Each and every BCD digit requires 4 bits. So the total maximum number of combinations of binary should be 2 power 4, which is equal to 16 with these 4 input variables. But out of these 16 only we are using from 0 to 9 only. Totally 10. The remaining 10 to 15, these are unused numbers. So that we have to use these numbers as don't cares in K-map simplifications. Okay. Now we should write the output value based on the given problem. The output is the 9's complement of the BCD. 9's complement means which is obtained as 9 minus BCD, 9 minus decimal digit. So 9 minus 0, 9 minus 1, 9 minus 2 like this. So that I have written here each and every 9's complemented value of input. Okay. So 9 minus 0 is 9, 9 minus 1 is 8. Similarly, we should obtain up to 0. So these are the 9's complemented values. Now we should write the equivalent binary for these 9's complemented values. Okay. So 9 means again based on the binary weights of 1, 2, 4, 8. We should write the binary data. In red color, I have written the 9's complemented of input values based on binary weights 1, 2, 4, 8. Okay. So 9 means 1, 0, 0, 1. 8 means 1, 0, 0, 0. Similarly, 0 means 0, 0, 0, 0. So that we have to fill all these values carefully. Now we should write the Boolean expressions for the output variables from this truth table. Now here from 10 to 15, I am using these numbers as unused numbers so that in K-map simplification from 10 to 15, I have to consider as don't cares. Okay. Now we should write the Boolean functions for output variables W, X, Y, and Z. Here I have written the Boolean expressions in SOP forms. Therefore, W equal to the SOP form operator is sigma. Sigma means summation of the product terms or min terms. So sigma M of, here in these two positions only we have ones. So the corresponding decimal digits are 0 and 1. So 0, 1, these are only min term numbers. Okay. Similarly for X, here 1, 2, 3, 4. In these positions we have ones to write the min term numbers for SOP form. So these 4 nothing but 2, 3, 4, 5. Okay, that's why I have written x equal to sigma m of 2, 3, 4, 5. Next for y, these two and these two. Okay, so for these two, the numbers are 2, 3, and for these two, the numbers are 6 and 7. That's why I have written as 2, 3, 6, 7. Similarly, for z also, we should write the min-term numbers 1, 1, 1, 1, and 1. So this is the equivalent value of 0. Next one, 2, 4, 6, and 8. Okay. So in this way, we should write the equivalent min-term numbers for the output variables. Now we should obtain the simplified Boolean functions with the help of the k-maps. Here, this is the first Boolean expression w equal to sigma m of 0, 1. This is the 4 variable k-map because the input variables are a, b, c, and d. So the leftmost 2 variables should take on left side, the rightmost 2 variables should take on right side. Okay. Now here this is the 4 variable k-map with the min-term number boxes 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15 based on these values. Okay. For AB 2 power 2 combinations of binary, we can write it is equal to 4. 4 means 0 to 3. So it requires 2 bits 0, 0, 0, 1, 1, 1, and 1, 0. Similarly, for CD also 0, 0, 0, 1, 1, 1, 1, 0. So 0, 0, 0, 0 means its equivalent min-term is 0. So in this way, we should fill all these min-term numbers. From 10 to 15, we have to fill with the don't cares in k-maps. And the min-term numbers of W Boolean function should be filled with the ones. Now try to make groups with the help of ones and don't cares. These two ones are adjacent to each other. There is no adjacency of other don't cares. Okay. So we can leave any number of don't cares as empty. Okay, without making group. So the final simplified Boolean expression for this W is here this group lies in first row and these two columns. In first row means 0, 0. 0, 0 means for the SOP form. 0 means complement form. 1 is normal form. 0, 0 is A dash, B dash. Now vertically for C value 0, 0. Therefore C dash is common. For D 0 and 1. That means D dash and D. Okay, D dash plus D is equal to 1. Okay, according to Boolean postulates. So we can eliminate D. Okay, therefore W equal to A bar, B bar, C bar. Okay, so this is the simplified expression for W. Next one for X. X equal to sigma M 2, 3, 4, 5. First we have to fill ones in the place of these min-term number boxes. Okay, 2, 3, 4, and 5. Now, when we try to make a group, 2, 3 are adjacent with 10 and 11 don't cares. Okay, these two becomes as one quad, 4 ones. This is the first group. Here, when we see these two are adjacent with these two don't care, so that I have made another group. Okay, this is a second group. Now, compare these two groups in one single k-map, then it gives us this is first group and this is second group. Now, based on these two groups, we should write the product terms for each and every group. Okay. So this is the first group. This is the second group. Okay. For the first group, this group lies in first row and last row and last two columns. Okay. In these two rows, A is neglected because it is having 0 and 1. A dash plus A equal to 1. B is 0, 0. Therefore, B dash is common. Next, vertically for C 1, therefore C is common. Okay. For D 1, 0, therefore D should be neglected. So, corresponding product term for the first group is B dash C. In the same way for the second group, the product term is the group lies in the two rows and these two columns. So in these two rows for A 0, 1, therefore A should be neglected. Vertically B for B 1, 1, therefore B normal form. Next vertically C 0, 0, therefore C dash. Okay, this is the product term for the second group. So now we should write the equivalent formula for this expression, which is equal to B XOR C. Okay. The same way for Y 2, 3, 6, 7. So first we should fill ones in the place of 2, 3, 6, and 7. These 4 ones are adjacent with these 4s. When we fold the k-map at this position, these 4 ones are overlapped with these 4 don't care, so that it makes us one octet. Now this group lies in 4 rows and last 2 columns. 4 rows means A neglected and B also neglected, because for A, 2 zeros and 2 ones, equal number of zeros and equal number of ones, so that A should be neglected. Similarly for B, again for B, 0, 1 and 1 0, therefore 2 zeros and 2 ones, again B also neglected. Vertically for C, 1 1, that means C is common. Okay, D 1 0, therefore D should be neglected. Therefore, the simplified Boolean expression for this K-map is y equal to C. Now the last one, z equal to sigma 0 to 4 6 8. 0, 2, 4, 6 and 8. And 10 to 15 are don't gets. Now should try to make groups with the ones and don't gets. These two ones and this one and these two ones. So here when we see these two ones are adjacent with these two. At the same time, these two ones, when we hold at this level, these 4 ones are adjacent with these don't cares and don't care and 1. So that these two makes us one object. Okay. So this group lies in 4 rows and these two columns. So 4 rows means A, B, both variables should be neglected. CD means for C, 0, 1. Therefore, C also neglected. D 0 0, therefore D dash. 0 means a complement form. Okay. Simplified Boolean expression is Z equal to D dash. Okay. These are the simplified Boolean expressions with the help of the K-maps. Now we should draw the circuit diagram based on these simplified Boolean expressions. So to draw this circuit diagram, first we should draw the vertical lines. Okay. For A, input variables B, C and D. After that we should connect NOT gates in series with A, B, C, D to get the values of A dash, B dash, C dash and D dash. Now the first expression is W equal to A dash, B dash, C dash. So that this is a 3 input AND gate. So this is 3 input AND gate. For this, the input is A dash, B dash and C dash. So put a node and connect from this point to the first input. Similarly, second input, third input. The output is W. In the same way, X equal to B XOR C. XOR gate B is this is the connection. Next C means from this we have the connector. So output is X. Similarly, Y is equal to C. Therefore, Y output which is connected to directly C. Okay. Next Z equal to D dash. The fourth output. Next this is a connection from D dash. Okay. In this way, we should develop the logic circuit diagram with the help of the logic gates. Okay. So I hope you understand this concept very easily. If you like my video, please like and subscribe to my channel DLD Quest. Thank you.